have liftoff.
Space-based observatories provide us with a unique view of solar activity. In 2006, NASA launched twin state-of-the-art satellites to study at close hand solar storms and sunspots, visible signs of deep magnetic activity that affects the whole solar system. The scientists borrow a trick from 1950s B-movies to create a 3D image of the sun. They deployed two satellites orbiting in tandem, one in front of the other, so they can build a three-dimensional image back on Earth. This 3D image will provide crucial new data on massive explosions of electrified plasma called solar storms. Billions of tons of superheated gas fly into space and buffet the Earth's atmosphere, creating the most dramatic northern and southern lights. Michael Kaiser of the Solar Terrestrial Relations Observatory, or STEREO.
We want to monitor these storms so that we can better predict them. These storms are basically electrical storms, and they can affect spacecraft, ground power systems. The GPS can be upset.
Solar storms are caused by lines of magnetic force ripping through the sun's gaseous surface and snapping, spewing out hot gases and a fierce stream of charged particles, the most powerful type of what's called solar wind. Some storms take 2 days to strike the Earth, while very large ejections arrive in only 12 hours. STEREO could give us time to put satellites and electric power grids into safe mode and move astronauts into protected sections of the space station.
The ones we're interested in, the ones coming right at us, are particularly difficult to estimate the speed and velocity.
A simple demo shows how two satellites allow scientists to calculate the speed of this solar wind. Michael Kaiser ejects a jet of liquid at a plate of glass. From the front, it's difficult to measure the speed. This is the way older satellites used to view solar storms. But from the side, you can measure 2 points along the projectile and calculate the speed more easily. Studying solar storms not just from the front, but the side as well, doesn't just reveal their speed, it also shows where they come from. The answer turns out to be the area around sunspots. These dark spots on the sun's surface were shrouded in mystery until the 20th century, when scientists realized that they were connected with the way the sun generates heat at its core. Once scientists understood that the sun got its energy from nuclear reactions, the answer became clear. Nuclear fusion within the sun creates the conditions for powerful magnetic effects. The currents of superheated gas generate intense magnetic fields. As the sun's interior churns, vast loops of magnetic force appear, merge, and disappear, creating sunspots. Luckily, there's a way to visualize it right here on Earth, in the comfort of your own kitchen. NASA astronomer Sten Odenwald compares magnetic field lines to spaghetti.
The surface of the sun is very hot gases that are turning over in a boiling motion. What you're seeing in the pot of water is the convecting water coming up to the surface and releasing its heat and then sinking back down into the pot to get reheated.
The rolling strands of spaghetti are like the magnetic field lines churning beneath the sun's surface.